I remember I spent the day at Pal's, which is a bookstore in Portland, one of the biggest, and they have a whole room devoted to software design. And I spent the day there looking through software design books, a range of books, design and analysis books. And they basically all said the same thing, which is to think about what it is, the entities in the domain that you're working in, and then make them your objects, define them as classes, and then look for the commonality between those classes, anything that there's common behavior, and start to compose hierarchies and create these inheritance hierarchies this way. And this is your design. And it sucks. The end result is pathetic. It's horrible. If you do this, you're going to find that it is not very good. And what we really want to do is find ways of building our software so that the business rules are concentrated. Not necessarily in a single object, but concentrated in a group of entities. And that's our domain model. And usually it's the relationship between those entities and how they interact that define our domain model. We want to create behavior through the interaction of the entities, of the objects in our system, rather than through straight logic. And we do that through polymorphism, through a whole range of other techniques, which are exemplified through design patterns. Design patterns show us how to do many of these techniques. So just understanding the basic Gang of Four 23 design patterns, is so valuable. It's opened my mind so much, and not just in software development, although it has made me a master in software design, but in every area of my life, really. Understanding design patterns has made me aware that there's another level of understanding that's pattern-oriented, that reality is not just logical, but it also follows these complex patterns that have influences. Think about it this way. We can model the world logically, right? Through conditional statements as rules. If this, then that, right? Or we can model the world through abstractions, through generalizations. When these things happen, those things happen, right? They're different. So abstractions are, in a sense, a higher level representation of conditionals. And the idea in good object-oriented design is to get rid of conditionals in our objects as much as we can, because in OO, everything in OO is about doing one thing. It's single-minded. And unfortunately, conditional statements are dual-minded. They have two responsibilities. They have two concerns, which is the condition itself and the action, right? If this, then that, right? This and that are two different things. And because they're two different things, they're dependent upon two different things. They're used in two different ways and at two different times, et cetera, et cetera. So they should be split apart. And that's really the intent of OO. That's one of the most fundamental things in OO. And I don't see many people following it. Yeah, there's dependency injection and Spring. These are frameworks that do instantiation, And these are good because they manage instantiation. But really, these are things that I like to manage myself. Because I really like to understand the lifeline of my objects. I'm quite surprised that this isn't a priority for developers. I always try to think about when do I instantiate? How do I instantiate? Because so much can be resolved in the process of instantiation. If we separate out, again, separation of concerns, this is a big one, separate out these two concerns, which is creation of our object, instantiation, putting it into a known good state, and then using it, right? By separating those two things out, we wind up eliminating or greatly reducing the amount of coupling between different objects. If you look at most people's code, and I've looked at millions of lines of code at the top companies in the world. So don't be embarrassed if I'm calling out some things that you do, because we all do it. A lot of developers do these things, which is they have these huge coupling. Like if I were to want to, for example, add a parameter to a method, oh man, those method signatures are locked down. Everyone's using it. And it's going to be a hell to go and change it in 5 million places. or changing a data structure, or there's any number of things that our code is brittle to. And so understanding those things, understanding different designs give us different trade-offs, different options give us different trade-offs, gives us the superpowers to be able to wield those trade-offs well, gives us the ability to be able to use the right design approaches for the design we're currently working with, okay? And it's going to be many years before AI can do this. So these are skills, I assure you, that will be useful in the future, which are how we abstract and how we think about things. Ironically, I've had many conversations with ChatGPT specifically about this. It has a deep understanding. It doesn't yet know how to apply it to code. It's actually really poor at code, but it is really good at understanding the nuances of abstractions and using that to communicate, which is a great part of what we do as software developers. I want to talk a little bit about abstractions. How can something that's non-executable, like an abstraction, be valuable in software development? In assembly language, things were very tangible, right? If you ever look at assembly, the instructions, the keywords are quite rudimentary, shall we say. Load a register, put a register, add two numbers together. The instructions in assembly language are quite tangible. They're quite specific. And as we got higher and higher levels of language, we go and ascend to higher and higher levels of abstraction. And these higher levels of abstraction help us conceptualize and understand. Not only allows us to understand, but allows us to organize the code that we write in such a way that it has purpose. It can be repurposed, which is really essentially important. And so I'm trying to find ways, not just ways that make sense, and especially not clever ways. I know a lot of techniques that are like, oh, I know this shortcut or that shortcut. We're not going to talk about any of that stuff. We don't talk about shortcuts because that's not how to build a discipline. To build a discipline, we want to have good technical practices that we always use, even when we don't really need them. If I'm doing a one-off, I notice that even if I'm doing a quick little prototype, oftentimes I'll build a test first. Oftentimes I'll think about what is the right domain model for this? Even if it's just a one-off, because it's my habit. It's the practice that I'm used to. And I think that's what being a professional is about, is having a set of practices that you adhere to, And so then understanding what they are is quite important. I maintain that developing enterprise software is every bit as complex and challenging and intricate as any other discipline. Rocket science, well, there's a lot of programming in rocket science, or brain surgery, or we think about the most intricate fields like medicine or the law. And I really akin software development very much to these fields because it requires a great deal of thoughtfulness. And, you don't have to get your PhD and, do residency. I wish we did, because then we would be able to learn more readily. It's like every one of us have to figure this complex thing out. Think about how backwards medicine would be if every single doctor had to figure out germ theory and microscopic organisms and everything else, I feel like that's what we do in our industry. In software, is like we reinvent the wheel over and over again. So let's build some tenets. Let's start building stuff in terms of the ideas that we create. And it all starts with design. It all starts with the separation of concerns. It starts with taking the jumble of ideas in our head and breaking them out. We're just talking about this one thing, separation of concerns. How do we build a model that represents whatever it is? Because you have stuff that you want to create, right? Maybe lots of things. So thinking about how is this model? Like if I were to draw it out on a whiteboard or on a piece of paper, and I would just make a circle or a box for each of the entities. What are the entities and how are they interacting with each other? That's the domain model. It starts out that simple, and it doesn't have to be complex, and it is definitely not detailed. Just the basic business rules. Because what we find is that the details are not in the domain model, that a lot of the details are actually in the implementation. And by separating them out, it becomes much clearer what's what. You know, I used to do a lot of prototyping with the UI. And I really liked that because it allowed me to create, you know, little designs that looked like the program that I was going to use. But I found that it was really bad practice because what I ended up doing was putting a lot of my business rules in the UI elements, because that was the first thing that I built, was the graphical elements. And now what I do is I prototype, but I prototype the most critical pieces, which typically is not the user interface, but rather the underlying entities. What are the entities and what are their states? Those are the things that we're really modeling, usually in a business process.
So I start there.
I will see you in the next one. Ciao.